All right, today we're going to talk about triangle similarity. All right, we've done similar figures before, so let's talk about what similarity means. Similarity means the angles are congruent, so all the angles are the same, and that the sides are just similar. All right, so we need to do that. Today we're going to talk about different ways to prove that triangles are similar. We'll talk about these in class, but today we're just going to show you what they are. You can do angle, angle. Okay? So if we know that this is like 87 degrees, this is 87 degrees. So that's one set of angles that are congruent. And then we can throw in, let's say, a 43 degrees here and a 43 degrees here. Okay? Because a triangle always adds up to 180, then you could say that the other one, this would also be congruent. All right, you could do 180 minus 130, and this guy over here will be 50. Okay, so technically we only need two angles to prove triangles are congruent, but because they add up to 180, it ends up being all three anyway. Another way that you can do this is side angle side. All right, so if we know that this side is congruent to this side, these angles are congruent, and these sides are congruent, then we can go ahead and do triangle similarity. And when we use similarity, we're going to use those proportions, so we'll talk about it. But we have side, angle, side. We also have angle, angle so far, and we're going to add another one. Side, side, side also works. Okay, so we have these three is what we're going to talk about. The new one here is side, side, side. So if we know these sides are congruent, these sides are congruent, or not congruent, similar, I'm sorry. If they are similar, that means their proportions are the same. Then we'll talk about that here. So here's what we're going to do. We're going to have these triangles, and we need to figure out if they are similar. So we're trying to make those ratios and see if they're all the same. If they're all pretty much the same thing, just reduce the fraction and so on and so forth. So here, I'm just going to start with 7 over 21. Okay? So this is QR over NO. NO. Alright, so QR over NO. 7 over 21. So we've covered 7, we've covered 21. Does that equal 10 over 30? Alright, so we're doing 10 over 30. And then we also have the other one, so we've covered these. We also have 15 over 45. Okay, if you simplify these are all equal to 1/3. So they all have the same ratio on the sides. And then we can talk about that these are similar triangles because of side, side, side. Okay, we have three sides that are all similar, or that are all proportional, so we can do side, side, side. Alright, so now that we have these, we can kind of go and make the actual similarity statement. So let me erase this. We have the similarity. We're going to go just P. Let's do Q, R, P. So Q is the one between the 7 and 10. So we're going to look at the one between the 7 and the 10, which corresponds between the 21 and the 30. So Q is going to match up with N. Now we're going to go to R. R is between 7 and 15. So the O is between the 21 and 45. So NO, and the only last one is the M. Okay, so that's how to write your similarity statements. Alright, same thing here. It doesn't look at first that it is going to be similar, but we need to check. We have 120 degrees, 120 degrees, and then we have a 40 here. Okay, but if we add 120 and 40, then that's going to give us 160, and then 180 minus 160 will tell me that this is 20 degrees. We could do the same thing to get a 40 degrees there. So this is similar by angle, angles. Okay, and we'll do ABC is similar, and A is the 40 degrees, so we're going to use here, over here is Z, and then we're going to go to B. B is the 120 degrees, so that's going to be our X, and then Y goes with our C, so we put our Y there. That's our similar triangles. Now, the other thing you can do, some of these is, you don't necessarily, not always can you prove that they are similar. Like this, we have 10 to 5, so we can do 10 to 5, 10 to 5, 8 to 4. So we have side, side, but we don't have anything else. So we cannot necessarily say these triangles are similar. All right, let's do some actual problems. The first step is, again, try to prove that they are similar. So in this case, we have 100 degrees, 100 degrees, and we also have vertical angles. So those angles are congruent. So we're going to use angle, angle, and say these triangles are congruent. Now, in this case, it's a little weird, but we have, it's kind of like flip. This is 10 corresponds to this side over here, to 15, equals, and then we're going to go with our X, and it's going to correspond to 20. Alright, so we can set up this proportion. Now we can start solving for X. So we're going to do this as 200 equals 15X. Divide by 15. Alright, and if you don't know that, get your calculator out. 200 divided by 15. Alright, gives us 13 and a third. If you don't know that, you can do a fraction. We'll say X is 13.3 repeating. Or you can go here and hit your math button and go to fraction. Give you 40 over 3. Okay, let's do one more. All right, so this is the case where we have parallel lines. Now, parallel lines are nice because we have certain things happen. This angle is congruent to that angle because they are corresponding. Okay, if you need to extend your line all the way out, it makes it look a little bit easier to tell. But those angles are congruent. And these angles are congruent as well because of corresponding angles. So we know these triangles are similar, and we're going to set it up like this, 3 over 9. So this side over the bottom part equals X over 12. Here we get 9X equals 36. Divide by 9, X equals 4. So we can type in here, X is 4. Okay? And that's what we're going to be doing in class.